Good morning, friends. Today we are going to see the next part. Today we are going to discuss the enthalpy, and we have to see how the MCQs will be there based on this particular topic. Enthalpy is nothing but the heat supplied at the constant pressure. Heat supplied at the constant pressure, which is corresponds to the change in enthalpy. It is then for change at the constant volume, that is delta V is equal to 0, W is equal to 0, since W is equal to P delta V. Therefore Q is equal to QV, that is the heat exchange at the constant volume. For change at the constant pressure, for this case enthalpy is mathematically defined as H is equal to U plus P into V, where U is the internal energy of the system, P is the pressure of the system, V is the volume of the system. Enthalpy is a state function because internal energy, pressure and the volume all are state function. For process taking place at a constant pressure, in the final state you can take the H2 is equal to U2 plus P2, PV2, pressure is constant. In initial state H1 is equal to U1 plus PV1. Therefore delta H is equal to H2 minus H1, that is equal to delta H is equal to U2 plus PV2 minus U1 plus PV1. Delta H is equal to U2 minus U1 plus P in bracket U2 minus U1, that becomes delta H is equal to delta U plus P delta V. Very simple it is. After substitution on all this thing, we have to take the change in enthalpy. We can't calculate the direct value of the enthalpy, but we can deal with the change in enthalpy. Consider a process carried out at a constant pressure and where work allowed is only pressure, volume, work, that W is equal to minus P delta V. Under this condition what will happen? The expression W is equal to P delta V, delta U is equal to QP plus W becomes therefore delta is equal to QP plus P delta V, since QP is equal to delta U plus P delta V. On compare equation number 1 and 2, you will get delta H is equal to QP, delta H is equal to QP, where it is a minus sign should be there, remember this thing, minus QP minus this, and when you exchange this thing at that time QP is equal to delta U plus P delta V. On comparing this equation you will get delta is equal to QP. Hence when the system is subjected to the constant pressure, only expansion work can occur. The change in enthalpy is equal to energy supply as a heat. The change in enthalpy is equal to energy supply as a heat. Okay, this may come for the MCQ purpose. And then heat exchange at a constant pressure is equal to change in enthalpy during the process. For chemical reaction, the enthalpy change is given by delta H is equal to H product minus H reactant. Case 1, if delta H is positive, then HP should be greater than HR. Hence it will be absorbed by the system and reaction will be the endothermic reaction. For the MCQ's purpose, it is very much important. When delta H is positive, it means enthalpy of product is greater than enthalpy of reactant. The MCQ will be on that. If the HP is greater than HR, then heat will be absorbed by the system and reaction will be endothermic. Whereas when the delta H is negative, that means H reactant, the enthalpy of the reactant will more than the enthalpy of the product. Hence heat is released are given out by the system, and reaction will be the exothermic. Are you getting this point? Very simple. This particular enthalpy is there. Then the heat transfer, it is extensive property. The process of the heat moving from one object into another called as heat transfer. It depends on the difference in temperature. It mainly occurs in the three ways. The definition, whatever the definition of the heat transfer is there, that may come for the your MCQ. Then the conduction, the process by which heat or electricity is directly transmitted. The process by which the heat or electricity is directly transmitted is called as the conduction. That you have to remember. Very simple it is. Then convection, it is the heat transfer due to the bulk movement of molecule within fluid. Then the radiation, it is the energy traveling through the space. These are the three ways by which the heat transfer is taken. Then the heat capacity is denoted by the C. Definition of the heat capacity, it is the capacity of substance in which the quantity of energy required to raise its temperature by 1 degree centigrade or 1 Kelvin. That is the what we can say. This is about this particular heat capacity. MCQ will be there based on this definition. There are the two types of the heat capacities: heat capacity at a constant pressure and heat capacity at constant volume. CP is nothing but heat capacity at constant pressure. CV is nothing but heat capacity at constant volume. Properties of heat capacity. Heat capacity differs from substance to substance. Heat capacity is different for different substance. The MCQs will be there like that. Heat capacity is directly proportional to amount of substance. Heat capacity is extensive property. Heat required to increase the temperature from 0 degree centigrade to 0 Kelvin. 0 degree centigrade to Kelvin of a substance can be calculated using the equation Q is equal to C into delta T. Units of the heat capacity is the joule per Kelvin. That you have to remember, because on all these properties, whatever the properties are there, there will be the MCQ based on this particular topic. Okay, please go through this part. Then specific heat capacity, it is the heat capacity per kilogram of the substance. Unit is the joule per kilogram per Kelvin. Molar heat capacity is the heat capacity per mole of the substance. Unit is the joule per mole per Kelvin. Heat capacity at constant volume is given by the equation Cv is equal to d into Qv divided by dt. Also you can write it as a Cv is equal to d by u by d by t at constant volume. Heat capacity at constant pressure is equal to Cp the remaining part we will see. This particular thing you have to highlight. MCQ, how that MCQ will be there. Please go through these things. Enthalpy part and the heat transfer. If you are not getting anything, you can ask on the Google Classroom or say WhatsApp group. Especially use the WhatsApp group for to clear the any doubt. See these cases because the MCQs will be there on this topic. Okay, these are the properties of the heat capacity. Then we have seen the specific heat capacity, molar heat capacity. Please go through it. If you are not getting any point, then you can ask. Okay, we will stop here. Thank you.